Hello, today we're going to learn about one-step equations when we're dealing with multiplication and division. All right, so let's review just a tad bit. When we were doing adding and subtracting, we wanted to create zero pairs to get the variable alone, right? We did opposite or inverse operations to get that variable by itself, and we did that by using zero pairs in the inverse operations. All right, when multiplying and dividing, we want to make the coefficient 1. So we want to get that number in front of the x a 1 because 1x is the same thing as x, because anything times 1 is itself. So we have to identify the inverse operations again. All right, so the inverse operation to multiplication is division. So here's an example. We have 5x equals 10. So I have 5 x's here. I just want to get 1x. So I can see I have 5 groups right here, and then that gives me down to 1. And over here, I have 5 groups, and in each group I have 2. I have 2 in each group of 5, so that means x equals 2. All right, so the opposite of multiplication is division, and the opposite of division is multiplication. All right, we use inverse operations to create 1 so that the variable is all by itself, because 1x is the same thing as just x, because 1 times x is x. All right, steps to solve one-step equations using division and multiplication. All right, so the first thing is we want to circle the variable. Then we want to identify the operation and then choose the inverse operation so we can solve the equation. All right, so let's try this one here. It says 4x equals negative 8. So I want to get this x all by itself. When a number is touching a variable, they're right next to each other like that, that means that they are multiplying. So I'm going to put an x for multiply. So I know I have to do the inverse of that. And the inverse of multiplying is dividing. So I know I'm going to have to divide. So I want to get that x by itself, right? So I'm going to divide by 4 because 4 divided by 4 gives me 1. And that's going to leave me with 1x, which is what I want. Because 1x is the exact same thing as just a regular x. And I'm going to do the same thing to the other side because this is an equation. It has an equal sign. To keep it equal, whatever you do to one side, we have to do to the other side. So negative 8 divided by 4 will give me negative 2. So x equals negative 2. All right? Just like the adding and subtraction problems, I can check this and see if I got it right. So instead of 4x, I'm going to plug in negative 2 for x. And 4 times negative 2 gives me negative 8, which is what they wanted. They wanted to equal negative 8, so I know I got it right. That's the great thing about equations is you can check your work instantly and know if you got it right or wrong right away. Okay, so let's try this one over here. So this says x fraction bar 3 equals 6. Well, a fraction bar means divide, right? So the operation here is they're dividing, right? So the inverse of dividing, or the opposite of dividing, is multiplying. So that means I have to times by 3. I'm going to put a dot because a dot can mean times by 3 to get rid of this 3 on this side and leave me with just x. And this is once again an equal sign, so whatever I do to one side, I have to do to the other side to keep it equal. 6 times 3 gives me 18. And that is my answer, x equals 18. And once again, I could plug this in and check my work right away. So it says x divided by 3, so I'm going to plug in 18 for x. 18 divided by 3 gives me 6, which is what they wanted it to equal, so I know I got it right. All right, so let's try this one. I see x fraction bar negative 2. So a fraction bar means divide, so I know that the inverse of that is going to be multiply. So I have to do the opposite. So I'm going to multiply by negative 2 to get rid of this, because negative 2 times the fraction of divided by negative 2 gives me 1. So I'm going to leave me with 1x, which is what I want. And I'm going to do the same thing to the other side. Because it's an equal sign, you have to do the same thing to both sides to keep it equal. 5 times negative 2 will give me negative 10. And that is my answer. Now once again, I can check my work to see if I got it right. So instead of x divided by negative 2, I can plug in negative 10 divided by negative 2. Well, a negative divided by a negative gives me a positive, and 10 divided by 2 gives me 5. So it'd be positive 5, and that's what they wanted it to equal, so I know I got it right. All right, this last one, I have negative 6x. So I want to get this x all by itself. When a number is touching a letter like that, that means that it is multiplying. So I need to do the inverse, or the opposite of that, which is divide. So I'm going to divide by negative 6, because negative 6 divided by negative 6 cancels out to give me 1x. And it's an equal sign here, so I have to keep it equal by doing the same thing to the other side. Negative 12 divided by negative 6. A negative divided by a negative gives me a positive. 12 divided by 6 gives me 2. So this would be x equals 2. And once again, I can check my work. So negative 6x, I can plug in 2 for x because we just solved for that and see if we get it right. So this would be negative 6 times 2, which is negative 12. And that's what they wanted it to equal, so I know we got it right. Okay, so whenever you have multiplication, the inverse to that is division. Whenever you have division, the inverse to that is multiplication. We have to do the same thing to both sides because it's an equal sign. We have to keep that equation equal. We have to keep it balanced. All right? Okay, sometimes you'll have fractions in front of an x. And the way to get rid of fractions is, if the coefficient is a fraction, we multiply by the reciprocal. Reciprocal. We multiply by the reciprocal. Okay, so the reciprocal is that we just flip the fraction. So this is 2 over 3, right? So the reciprocal of 2 over 3 would be 3 over 2. Okay? Reciprocal, or sorry, negative 6 over 5, the reciprocal to negative 6 over 5 would be 5 over negative 6. So reciprocal means we just flip the fraction. So when we have a reciprocal next to a variable like this right here, we have 2/5 x. I have a fraction as my coefficient, or the number with the variable. That means I have to multiply by the reciprocal. So I'm going to times this by the reciprocal, which means I flip the fraction. And the reason I do that is because 5 over 2 times 2 over 5, that cancels out and only gives me 1. And that's what I want. I want 1x. I want one variable, right? It's still an equal sign, so whatever I did to this side, I have to do to the other side to keep it equal, right? So 10 times 5 over 2. All right, so the way we times this is we take the whole number and we times it by the top. So 10 times 5 would give me 50. And then this fraction bar, remember, means divide. So 10 times 5 gave me 50. And now I can divide by 2. So 50 divided by 2 is 25. So x equals 25. All right, and once again, I can check my work like always. I can write 2/5, and then instead of x, I can plug in 25 and check my work. So just like how I multiplied this, I'm going to do the top number times my whole number. So 2 times 25 is 50. And then this fraction bar means divide. So I'm going to divide by 5. 2 times 25 gives me 50. 50 divided by 5 gives me 10. And that is what they wanted it to equal, because it says equals 10. So I know I got it right. Okay, so when we are doing one-step equations with multiplying and dividing, we have to use the inverse operation. We have to use the inverse operation so that we can get that variable all by itself. And the reason why we do that inverse operation is because, like 4x, if we divide by 4, that cancels out because it gives us a 1. So it's 1x, and 1x is the same thing as just x. All right, so we always want to do the inverse operation to solve equations. All right, so that is one-step equations with multiplication and division. Remember, best thing about equations is you can always plug it in and see if you got it right away. It'll tell you right away if you got it right or wrong. If you get something that didn't equal, then you know you did something wrong and you might want to try it again. All right, like always, if you ever have any questions or need any help, please ask your teacher, and I will see you next time.